We're going to set up for the Thin Layer Chromatography lab today, and we're going to have 6 knowns, standard samples, and then you'll have an unknown which has either 1 or 2 of these compounds in it. So we have 2-phenylethanol, also known as phenethyl alcohol, which is purchased from Acros. We have linalool, which was purchased from Acros. We have 2-phenethyl acetate, which came from Aldrich, or sigmaaldrich.com, the Aldrich chemical company. We have vanillin from Acros Organics. And we have guaiacol from Acros Organics. And we have eugenol from Acros Organics. So these 3 compounds are actually quite closely related. They have a benzene ring with a methoxy group and a phenol on it, and then they differ between whether or not they have another side chain. Vanillin has an aldehyde in the para position versus the alcohol, and eugenol has a vinyl group, an allo group. Guaiacol just has the 2 substituents. And then 2-phenethyl acetate and 2-phenylethanol are related, as this is the alcohol and this is its acetate ester. Linalool is quite different from the others. That's a monoterpene alcohol. It's got 10 carbons, 2 isoprene units. So 5 of these are liquids, 1 of them is a solid. We're going to measure out 20 or about 60 milligrams of each of these and dissolve it in 3 milliliters of solvent so that we have a sample concentration of about 20 milligrams per milliliter. So I'm going to go ahead and label up 6 vials so that we can take these to the balance and prepare our standard samples. So we got linalool, we've got 2-phenylethanol, we've got 2-phenethyl acetate, we've got guaiacol, we've got eugenol, and we've got vanillin. Eugenol is the kind of aroma compound that you'll find in cloves and vanilla. Obviously, vanillin is in vanilla. Guaiacol is probably the biochemical precursor to both of those compounds. And these are found in oak. So if you read about the aroma compounds in tequila, vanillin, guaiacol, and eugenol all come during the aging process, which is usually done in American white oak barrels. And some of those compounds are common to clove and vanilla and impart some of those same flavors to your liquor. The 2-phenylethanol and the 2-phenethyl acetate almost certainly derive from the amino acid phenylalanine during the fermentation process. And then linalool is actually produced by the agave. It's one of the monoterpene components that you'll actually be able to smell in the smell of fresh agave, along with alpha-terpineol, which you might guess comes from pine, and actually has the same kind of ring system as limonene, which you isolated from orange peel in the general chemistry lab. Alpha-terpineol has an alcohol down in that isopropyl side chain. All right, so we'll stick all these in our little test tube rack here. And take those to the balance. And make up our stock solutions. And I'll take 2 trips so I don't end up dropping everything all over. While from here, I can put these flasks back. So I'm just going to tear the vial. And then I want to drip in enough of the linalool. I have about 60 milligrams. I don't want to drip that on there, so I'm going to keep the ones as close as I can. It's not critical that it be exactly 60 milligrams, but we want a concentration of as close as possible to 20 milligrams per milliliter as we can get. Close these guys up so we can get a nice accurate reading. And it looks like we got 0.074, 0.7073, 0.0. It seems to be stabilized at 0.072. So we got 72 milligrams of linalool. And we got the 2-phenylethanol. It's important because of the air currents that it's actually be closed when you're tearing it. Phenyl alcohol. And it's just a few drops. Looks like we got 0.069 or 69 milligrams of the 2-phenylethanol. Move on to the 2-phenolphyl acetate. Except for the linalool, these are brand new bottles. They were just purchased for this lab. So I'm making sure I put nice clean pipettes in them so I don't contaminate them. And we've got 0.068 or 68 milligrams of the 2-phenolphyl acetate. My guaiacol. got 0.063 or 63 milligrams of guaiacol. One more liquid sample, eugenol. Very intense clove smell in the lab right now. And we got 0.079 or 79 milligrams of the eugenol. And the vanillin is a solid. So we'll be measuring that out with our little micro spatula. And to avoid spilling it on the balance, for this one, I'm actually going to take the vial out, put a little bit of sample in there, and then put the vial back in. And that'll give me an estimate how much more I need to add in order to get up to my 60 milligrams. It looks like that's stabilizing at 0.069 or 69 milligrams of the vanillin. And just in case I did spill a little bit, sweep that off. And now these samples can go back where they came from in our storage cabinet. We'll be using the vanillin again because that's also part of the extraction lab. A little spatula. The solvent I'm going to use to dissolve these is ethyl acetate. I'm relatively certain they'll all be freely soluble in ethyl acetate. And ethyl acetate is one of the components of the thin layer chromatography solvent mixture that we're going to use to analyze them. And I'm just going to turn off the camera for now because I need to go to the stockroom and get an automatic pipetter to